Hello everyone, I'm Raza Kayani. In today's lesson, I'm going to talk about density. You are watching revision series of high school physics. At the end of the video, I'm going to explain and solve some interesting exam questions related to density. By the end of the lesson, you will be able to describe the simple method to calculate the density. You will be able to use the ruler to calculate the volume by measuring length, width, and height of a solid cuboid. You will be able to determine the density of liquid by using measuring cylinder and an electronic balance. Finally, you are going to calculate the density of regular and irregular objects. Archimedes was a great Greek mathematician, physicist, astronomer, and inventor. He had designed a gigantic ship like Titanic in 3rd century BC by using the principle of buoyancy and gave the idea of density. Different objects have different densities. We have 3 cubic centimeter container. If the first cube is made from iron, and if the second cube contains a liquid, and if the third cube is made from wood. So we are going to see the masses and we are going to compare the densities. So in case of iron, the mass of the iron in 1 cubic centimeter is 900 grams. If we are going to insert water in the volume of 1 cubic centimeter, so the mass of the water in 1 cubic centimeter will be 1 gram for water. If we take one wooden cube, so the mass of 1 cubic centimeter of wooden cube is 0.6 gram. So 3 containers, they have a same amount of the volume, but the amount of the mass contained is different. Now I'll try to explain why the mass in each cube is different. In case of iron, in the nucleus, there are 26 neutrons and 26 protons. So it has a heavy nucleus. In case of water, in whole water molecule, H2O, we have the number of the neutrons, they are 8, and number of protons, they're also 8. So this is a molecule, and that's a single atom. Single atom contains large number of neutrons and protons, so that's why that's heavy. So if you are going to consider the atomic structure of 1 cubic centimeter of iron, and if you are going to consider the molecules of water, so they don't have a regular lattice and structure. So similarly, if the wood is solid, so they are going to be, so 1 cubic centimeter of wood has regular structure because they are solid, but they are far apart as compared to iron. That is how can we compare with the iron, water, and wood. So iron and wood, they have a regular lattice. They have a regular pattern. There's no space between the molecules, so they can slide past. But here, the molecule, they have a more space in case of liquid. 1 molecule of wooden material is lighter than 1 molecule of water, so it is less dense. 1 atom of iron is more heavier than 1 molecule of water, so iron is more denser. So the density of the material depends upon the geometry of their atoms and molecules. Hence, the mass of the atoms, their size, and how they are arranged determine the density, not the volume. Mass per unit volume is known as density. Mass per unit volume is called density. So the formula for the density is mass over volume. So density is going to be denoted by rho, that's the Greek letter, mass by volume. Or if you feel difficulty to write rho, you can write D equals to mass over volume. So where M is the mass of the material in kilogram, V is the volume in cubic meter, and rho is a density in kilogram per cubic meter, and the smaller unit of the density is gram per cubic centimeter. That's the smaller unit, and that's the bigger unit. This is a SI unit. Kilogram per cubic meter is a SI unit for the density. Now I'm going to consider 1 cubic meter. 1 cubic meter is a big container, which has a length of 1 meter, that has a width of 1 meter, and the height also 1 meter. So the volume of 1 cubic meter will be 1 meter times 1 meter times 1 meter. That's going to be 1 cubic meter, the volume. Now, in case of steel, in 1 cubic meter, we can fill 800 kilogram steel, or 1 cubic meter packed steel contains 8,000 kilogram mass inside. Similarly, if we have 1 cubic meter of wood that has only a mass of 800 kilogram inside. So if we are going to divide the mass of the steel divided by mass of wood, the answer over here is 10. So that means steel is 10 times, denser than wood. Now we can practice some question how to calculate density. An object has a mass of 1,200 kilogram and a volume of 3 cubic meter. What is the density in kilogram per cubic meter? So the first of all data, we can make the data of it first. The given mass is 1,200 kilogram and volume is 3 cubic meter. So formula for the density, rho equals mass over volume. So mass is 1,200 kilogram, volume is 3 cubic meter. So our answer will be 400 kilogram per cubic meter. We can use this triangle to calculate the value for the mass. For example, here we want to calculate density, so we can hide density. So density equals mass over volume. If we want to calculate mass, then we can hide mass, so mass equal density times volume. If you want to calculate volume, we can hide V, so volume equals mass over density. Those students, they feel difficulty to memorize these formulas. They can use these triangles to find the density, mass, or volume. Now we can practice how to calculate the volume when density and mass is given. Liquid water has a density of 1,000 kilogram per cubic meter. Calculate the volume occupied by mass of 500 kilogram. So the value of the density is rho. Again, those they cannot write this symbol rho, they can write the D. The value of mass is 500 kilogram. So we can use the formula. As I said earlier, we want to get volume in this case. So we can hide V. So V equals mass over density. So mass is 500 kilogram and density is 1,000 kilogram per cubic meter. So the answer will be 0.5 cubic meter. Now we can practice how to calculate mass when volume and density is given. What is the mass of the volume of 6 cubic meter of rock of density 2,000 kilogram per cubic meter? So here, first of all, we are going to write the data, what is given and what is unknown. So the given first thing is a volume, that is 6 cubic meter, and the density is 2,000 kilogram per cubic meter. So we want to calculate mass in this case. So again, we can use the formula. We can hide the mass. So if we are going to hide mass in this case, so mass equals density times volume. As here, we can multiply in the same way. So density, that is 2000 kilogram per cubic meter, and the volume is 6 cubic meter, and the volume is 6 cubic meter. So the cubic meter can be cancelled out. So 2 times 6 is 12. So the answer is going to be 12,000 kilogram mass. So the answer will be mass of 12,000 kilogram. Now I'm going to explain to you how to find the density of a liquid. To find the density of the liquid, first of all, we take a measuring cylinder. That measuring cylinder should be empty. There shouldn't be no liquid inside of it. There should be 2 precautions to read the meniscus of a measuring cylinder. If we don't have a measuring cylinder, we can use empty beaker to calculate the density of liquid. What are the 2 precautions? In case of mercury, we use the top meniscus. This is a case of mercury. And in case of water, we take the reading from the lower meniscus. So the top meniscus, that looks like convex mirror, and the lower meniscus, it looks like concave mirror. So in case of water, take a reading from the lower meniscus of the liquid, and in case of mercury, read from the upper meniscus. Now, after recording the mass of M1 of the empty beaker, now we can add some amount of the water inside the beaker here. This reading, if in case this reading is M1 for the empty cylinder, so after filling some amount of the liquid inside, we can find the second mass M2. So that M2 will be a mass of the liquid and mass of the beaker, or mass of the measuring cylinder. So we can calculate the mass of the liquid by using the following relationship. So the mass of the liquid can be calculated by the following relationship, where M2 is a mass. This is a M2. M2 is a mass of the beaker plus water inside both. And M1 is mass of only empty beaker, that is M1 here. So by subtracting M2 from M1, we can get the mass M. That's the only mass of the liquid. So we can use the formula density equals mass over volume to calculate the density of the liquid. To understand above concept, we can solve this question. The diagram shows an experiment to find the density of a liquid. What is the density of a liquid? So in this case, we want to calculate the density of the liquid. M1 is the mass of the empty measuring cylinder, and M2 is a mass of the cylinder plus water. So that mass is 250 grams. Here's a M1, and here is M2. So we can calculate only the mass of the liquid, that equals to M. M is 250 minus 200. That's going to be only 50 grams. Now we are going to decide what's the volume. So volume we read from the measuring cylinder. So that reading is between 20 and 30. That's going to be 25 unit. Here it's marked with cubic centimeter, so I'm going to write cubic centimeter. So to find the density, I'll use the formula rho equals mass over volume. So mass is 50 grams, and the volume in this case is 25 cubic centimeter. So the value of the density is going to be 2 gram per cubic centimeter. Now I'm going to talk about the density of a regular solid object. If I have this kind of the solid object that has a length, width, and height. So to find the density, first of all, we can calculate the volume of the cuboid. And the formula for the volume is length times width times height. The mass of the same cuboid, we keep it on the top and balance and to get the mass of the regular object by this method. Now we can practice another question to understand how to calculate the volume of a regular shaped object. So here we have one room that has a length of, that has a one dimension 4 meters and the other dimension is 6 meters and one of the dimensions is 8 meters. So we can find the volume of that room. The volume of the room is 4 meters times 6 meters and 8 meters. So the volume of the room is 192 cubic meter. Now, a room measures 4 meters, 6 meters by 8 meters. What is the mass of the air trapped in the room if the density of the air is 1.3 kilogram cubic per meter? So we have to calculate mass in this case. So we have the volume and the value of the density is 1.3 kilogram per cubic meter. So we can find the mass. So simply we can hide M. So M equals rho times V. So density is 1.3 and the volume is 192. So we can multiply to get the mass of the air inside, that is 249.6 kilograms. So in this room, this much air is a big number. To understand how to calculate the density of regular object, we can practice another question. A shopkeeper places 2 identical blocks of cheese on a set of scales and notices that their combined mass is 240 grams. Each block measures 2 centimeter by 5 centimeter by 10 centimeter. What is the density of the cheese? So we want to calculate the density of the cheese. Here they gave us the masses of the 2 blocks and the dimension here given is only for the 1 block. So mass of the 2 is basically, the mass of the 2 block is 240 and I have to calculate the mass of 1, so I have to divide it by 2. So my mass for each block here will be 120 gram. So this is the mass of each block. Now I can find the volume of each block. That is 2 centimeter by 5 centimeter multiplied by 10 centimeter. That's going to be 2 times 5 is 10 and 10 times 10 is 100 cubic centimeter. So to find the density, we can use the formula simply rho equals mass over volume. So the mass is 120 gram divided by volume is 100 cubic centimeter. So we can find the density of the 1 block of the cheese, that is 1.20 gram per cube. Now I'm going to talk about density of an irregular shaped solid. To calculate the density of irregular object, first of all, we need to calculate the mass of that object with the help of the top and balance. After that, we take a measuring cylinder and we insert some amount of liquid in it and mark volume V1. After that, we tie the solid object by a fine thread and dip it gently into the liquid and measure the volume V2 of the liquid plus the volume of the solid object. So here is a V2 for the object and for the liquid. Then we can use the relationship V equals to V2 minus V1 to calculate the volume of the solid. In this question, we can practice how to calculate the density of an irregular object. A student wants to calculate the density of an irregular piece of a metal having a mass of 44 grams. The following figure shows the volume of the water in both measuring cylinders. Calculate the density of the metal. So first of all, we can find V1, and then we can put the irregular object inside, and we can find the other volume, that is V2. As the mass is given already, that is 44 grams. So we can find the volume first of all. So V equals V2 minus V1. So our V2 is 50 cubic centimeter. All measuring cylinders, they are labeled with cubic centimeter or with ml. And V1 is 40 cubic centimeter. So the volume of the irregular object is only 10 cubic centimeter. We can use the formula for the density, mass over volume. Our mass is 44 grams and the volume is 10 cubic centimeter. So the density of the solid is 4.4 gram per cubic centimeter. Finally, I'm going to explain how to calculate the density of light objects like wood or bottle cork. So to calculate the density of the wood, first of all, measure the mass m of the wooden block by using the balance. The same method is used to measure the density of a bottle cork. First of all, we measure the volume V1 of the liquid only. And then we can dip the object inside and sure that the level of the liquid is going to rise. And we can find the second volume, V2. To find the density of the cork, first of all, we lower the piece of the metal into the beaker and record the new volume of the water displaced V2. So if we are going to only dip metal ring, not the cork, so we can find the volume V2. We can attach the metal with the cork and we can calculate the last volume. We can attach cork with the metal and we can find the volume of the water plus metal plus cork, and we can say that's the volume V3. So this way we can find the volume of the cork, and we are going to use this relationship to calculate the volume of the cork. We are going to subtract from V3, we are going to subtract V2 and V1. So that would be the volume of the cork. And we can use the formula of the density mass over volume to calculate the density of the cork. For those students who want to practice more questions, I have collected a range of past paper questions from 2002 till 2019 from different variants being examined by the University of Cambridge worldwide. The answers of these questions are available to the website. Thank you for watching. Subscribe to the channel to receive the next lesson. So finally, we can conclude that